Hey everyone, this is question number 34 from chapter 13. So this problem is about a child letting a balloon go. At sea level, the helium balloon is at 20 degrees Celsius, and then when it gets to an altitude of 3,600 meters, the temperature is 5 degrees Celsius, and the pressure is only 0.68 atmospheres, okay? So let's start by looking at the ideal gas equation. We're assuming that amount of gas is staying the same, and then R is constant, so we can divide T over and have the relationship PV over T, P1 V1 over T1 equals P2 V2 over T2. Okay, so we're given temperatures. We're solving for volumes, and we need a relationship between pressures, okay? So let's look back here at the question. Helium balloon starting at sea level. Sea level keyword here is going to mean 1 atmosphere. Okay. So then it says when it gets to this height, the pressure is 0.68 atmospheres. And 0.68 is about 2/3 of 1. So we can say that air pressure decreased by 30%. So we can assume that the pressure inside the balloon also only decreased by 30%, okay? So keep that in mind. So P decreased 30%. Okay, so now we can solve this equation for a relationship between volumes. How will the volume compare to that at sea level? So we're going to do V2 over V1. Okay, so we solve this equation for V2 over V1. We get V2 over V1 equals P1 over P2 times T2 over T1. Okay, so now we can plug in all of our values. So we said that for pressure, it decreased by 30%. So we can just set up a ratio. So the original pressure was 1. 30% less than 1 is 0, is 70%, which is 0.7. Okay, so that's going to be a relationship between pressure. And then temperature, we need to convert it to Kelvin, 273.15 plus 5 over 273.15 plus 20. That's Kelvin. All right, plug all that into your calculator, and you get a value of 1.3954, which we can round to 1.4. So we say that the volume at this high altitude is 1.4 times the original volume. I don't know why I wrote a 4. Original V.